In this video, we're going to cover how to graph secant, cosecant, tangent, and cotangent graphs. In the previous video about unit circles, I went over the definition of these various trigonometric functions and their relationships to sine and cosine. You'll see a little bit more here today, and we'll just jump in and get right to it. The first graph we're going to do is cosecant. Now, in the previous video, we said that cosecant was a reciprocal of sine. In other words, cosecant of an angle, and we're going to call this theta, the most common angle reference we use in trigonometry, is equal to 1 over sine. So cosecant is 1 over sine. It's the reciprocal. So what I've done here, as you can see in the graph, is I've graphed in purple lightly the graph of sine. And what I want to do is I want to flip it over. I want to take its reciprocal. So I'm going to actually note some key points, the peaks, the valleys, and the midlines, and we're going to flip those numbers over. So I'll show you how that works. What is it right here? So that first peak, the value of sine there is 1. Well, what's the reciprocal of 1? Well, 1 is equal to 1 over 1, and if I flip that over, it's still 1, which means that that peak, sine, and cosecant are identical. So there's no difference between the two. Well, what about down here at one of the valleys? Well, that's when sine is equal to -1. It's down at the bottom at -1. So up here is 1. Down here is -1. Okay. This is from the previous videos. Well, -1 is -1 over 1. And if I flip that over, I get 1 divided by -1, which is still -1. So it means that at the peaks and the valleys, cosecant and sine are identical. Well, what happens here in the middle? What happens when it crosses this x-axis in places like this? What happens when I take the reciprocal of 0? Well, 0 can be 0 over any number, so let's just do 0 over 1. If I flip that over, if I flip this over, I get 1 over 0, which is undefined. It's not a number. We can't plot it. We can't graph it. And when this happens in graphs, we typically have something called an asymptote. So every time the purple graph crosses the middle, I'm going to go ahead and draw an asymptote. So there we go. I'm going to go back here, and I know that all the peaks and valleys, they're identical. The value of sine and the value of cosecant are identical at these peaks and valleys. So the peaks and valleys, I'm going to fill in a red dot because that's where cosecant is going to be equivalent to sine. And the question is now, well, what happens in the in-between? And I'm going to explain a little bit of how that works, but first I'm actually just going to graph it. I'm going to show you what happens in between and then explain why. What you see in solid red is the graph of cosecant. You might say it kind of looks like a parabola going up and down. They aren't a parabola shape because they have asymptotes and parabolas don't, but you could generally think of it as that sort of general U shape. And what you see here is that the bottoms or tops of those U shapes are shared with sine. So to find out where they are for cosecant, if you graph lightly, like I did here, sine, you can quickly find where the bottoms and the valleys and the peaks are for our cosecant. And then all you need to do is using that original sine graph is find all the asymptotes, and then you can graph this. Now, but why does it do this? So again, cosecants are reciprocal. So I'm going to go ahead and take a look here, and I'm going to use a little bit of a darker color to highlight this. So say I see sine coming. We know that the reciprocal of 1 is 1. Well, what happens if I start coming down from 1? Well, those are numbers between 0 and 1, meaning that there's some sort of fraction or some sort of number that's just less than 1. Well, what happens if you take the reciprocal of a number less than 1? So, for example, what if you have a number of 0.5? If I want to take the reciprocal of 0.5, 0.5 is 1/2. The reciprocal of 1/2 is 2 over 1, or 2. In other words, it got bigger. It got bigger, and the smaller that number, so say this is 0.1, that's 1/10. The reciprocal of that is 10. And as I get closer and closer and closer to 0, 0.001 is 1 over 10,000. Did I do that right? Yes. If I take the reciprocal of that, that's 10,000. That means that number is just growing and growing, bigger and bigger as I get closer to 0, which is why the asymptote exists. When I get to 0, there is no value, but as I get super close, that number gets super large, and that's why it goes up those asymptotes. So to sort of just pull right back, cosecant and sine, their graphs are so closely related that I actually recommend sketching a small graph of the sine graph using the principles we've used previously, and then graphing the sine graph. And we'll get some examples of that in a later video. Now let's go to secant, which is the same exact principles as cosecant, except now we're dealing, it's a reciprocal of cosine. Same principles. Peaks and valleys are the same, so let me just fill those in with a dark blue. Next principle, all the places it crosses through the middle, I have an asymptote. Once I have these two things, I can graph my graph by making those solid blue dots that are the peak and valleys. They essentially become the inverted. So if it was a peak, now it becomes a valley, and if it was a valley, it becomes a peak. Okay, there you go. There is our secant graph. All right, now let's move on. I told you that we were going to do tangent and cotangent. This is where it gets a little bit more complicated. So let me hide this layer and bring up the tangent layer. And you'll notice that on each one of these, I've gone in and graphed both sine and cosine. You can see it in the unit circle why this is true, but we haven't really focused on this. But I'm going to give you two trig identities right now that you're going to need to have in your back pocket. First of all, we have this trig identity that the tangent of theta is equal to the sine of theta divided by the cosine of theta. You can see this in the unit circle because tangent is the y-coordinate divided by the x-coordinate, and sine is the y-coordinate, and cosine is the x-coordinate. So tangent of theta is sine divided by cosine, and since cotangent is its inverse, that means it's cosine divided by sine. And so this is why I have graphed both of them, because I need to do a division between both of them. First of all, tangent is sine over cosine. So let's go ahead and look where sine is equal to 0. So sine is equal to 0 at all of these mid places, right here, and right here, and again, right there. So sine is equal to 0 there. Well, what's cosine equal to at those same places? Well, this first one, at the where the sine is 0 at the origin, cosine isn't 0 there, it's 1. So at that place right here, I have 0 divided by 1, or just 0. If I look at the next place, I have 0 for sine and negative 1 for cosine, which is also 0. In every place that sine is 0, cosine is either 1 or negative 1, meaning that 0 divided by 1 or negative 1 is still 0. So everywhere sine is 0, tangent is 0. So I know that everywhere this purple graph, this lightly shaded purple graph, crosses the middle, that's where its value is 0, I'm going to have the same place for tangent. Okay. All right, what happens when cosine is 0? What about the places where cosine crosses that line? For example, if I look at this place, I have sine is 1 divided by cosine being 0. If I look here, this is where sine is negative 1 and cosine is also 0. So dividing by 0 now, just like the last time, is going to give me an asymptote. So everywhere where cosine crosses the middle, I'm going to have a vertical asymptote. Okay, so now there's a lot of stuff going on right now, and I actually have not graphed the tangent graph except for those dots where I know that it's 0. So I have to make an observation what's happening around these asymptotes. And just like before, I'm going to go ahead and graph what's happening and then explain. Okay, so there we go. There's your tangent graph. Now, why does it go up the asymptote on one side and down the asymptote on the other? So let me point this out. Let's just look at this region right here. If you look and you can see closely, the cosine and the sine graph are both positive. But the sine graph is going up to 1, and the cosine graph is going down to 0. And as we said the last time, say I had a number that was getting really, really, really close to 1, and I divided it by a number that was getting really, really close to 0. that's going to get bigger and bigger and bigger. Just like with cosecant and secant, as we were dividing by numbers closer to 0, it became a larger number. So that's why it goes up. If we look at this section over here, in this section, the value of sine is negative, but the value of cosine is positive. And when you have a negative divided by a positive, that results in a negative number. So the same pattern is happening. The numbers are getting bigger and bigger and bigger, just like on the other side. But the direction is different. Instead of them getting larger in value positively, they're getting larger in value negatively. So there you go. There's the tangent graph. The one thing that you're gonna that maybe you've noticed by now is that it actually repeats itself more frequently than sine and cosine do. So sine and cosine take all the way to 2 pi, which is all the way to 1, 2, 3, 4 to here to repeat itself. But in that same time, tangent repeats itself twice. So we'll see this in the next video, but tangent's period is officially half as big because of that. And guess what? Cotangent is going to be the same way. So let's do cotangent. It'll be much quicker on this part. Okay, cotangent, the top is cosine. So when the top is 0, cotangent is 0. So when cosine is 0, cotangent is 0. So let's go ahead and draw that in. Cosine being the green graph. Okay, so when cosine's through the middle, cotangent's through the middle. Now, for cotangent, sine's on the bottom, so when sine is 0, I have a vertical asymptote. Okay, now, and let's go ahead and graph this. Note, what I'm going to note is when sine and cosine are both the same sign, when they're both positive or both negative, I'm going to go up the asymptote, and when they're opposites, one's positive, one's negative, I'm going down that asymptote. Okay, as you can see, cotangent actually is essentially flipped over when it comes to the asymptotes, but it's also shifted over. That's actually a property we'll explore in later videos. But there you go. There's how to graph cosecant, secant, tangent, and cotangent. In the next video, we'll actually calculate the amplitude and period of these functions.